Hi everyone, my name is P.H. Charbonneau. I'm a senior IT consultant and the author on Java support pattern.blogspot.com. Today's tutorial will be basically demonstrating you the Oracle WebLogic 12c thread monitoring capabilities. I know some of my readers have been asking me for this type of training, so that's what we're going to show you today. I'm going to show you a couple of tips and tricks how you can use the WebLogic console to monitor the JVM threads, more precisely the WebLogic thread pool, which is very crucial if you're a WebLogic administrator. So I'm going to demonstrate to you how you can monitor the Hugging thread and also the stock thread using the console. So I really hope that you will enjoy this tutorial. So in order to understand the thread monitoring, what we did, we created the local WebLogic 12c environment. And we created a simple Java program. And with this Java program, we're going to demonstrate how you can monitor the threads in WebLogic 12c, and more precisely, how you can troubleshoot hugging threads and stock thread problems, which is a very common problem if you're a WebLogic administrator. So what you can see here is the WebLogic 12c administration console. So I'm going to log on to the console now. As an administrator, you're probably quite familiar with this. So we created a very simple domain. It's called PH Training. In terms of servers, if you go under Environment Servers, you can see that we have only one server, which is the admin server. So in this case, we're using the admin server also. Since we're pretty much in development mode, we're going to deploy this application to the admin server, meaning that the actual console and the application is available to that same instance. Okay, so in order to monitor the actual threads, you need to go as I just did under servers. Then you select your server, which is, it could be manage server 1, manage server 2, and then you go under monitoring, and then you can see there's a threads tab right here, and this is where you will see the actual sections to monitor. So we'll start with this approach because it's very important that you understand, and because sometimes a lot of people, when I see when I review some team or some clients, they are not taking advantage of this. So especially if you're dealing with a live problem, it's important that you understand this. So you can see here that you have a summary, right, of the situation. So active, if you probably saw my other articles when I was describing this, the active executed threads, as you can see, it's a little confusing if you look at all of this, right? But the way to read this is pretty much like this. This is the execute thread total. This is a total number of thread created by WebLogic, right? Because that's a self-tuning thread pool, which will grow and shrink depending of your application workload. Okay, so the execute is pretty much the total number of thread that WebLogic created, and then depending of the traffic, you may have some active threads and idle thread, right? So this one is the total number of active, meaning that you have 24 thread total created. Out of 24, 23 are active. One thread is in standby mode, meaning that it's not ready to process yet, right? So WebLogic will create thread, will promote them to active state depending on your workload. It may decide to put some of thread in standby if the load is too low, for example. And then out of 23 active thread, you have 21 which is idle. Idle means you have 21 threads available to process transaction. Okay. And the reason you have 21 idle is because if you scroll down, you'll see you have thread 4 and thread 6, which were actually executing a request at the time we did a refresh of the page, right? Because this thread, you can see it's the console app. So just using the console when I was refreshing this page was using the thread number 6, and then because the console is pulling the data from the JMX server, then it triggered another call, another thread, which is RMI connection in this case, right? So you have two threads executing a request in this case. So which is why you get 23 threads minus 21, right? Which is these two threads. So when you look at this portion, typically the counter that you care about, or this one, the idle thread count, right? Also the queue length, but more importantly the hugging thread count. Okay, the hugging thread count, it's a new counter that was introduced by WebLogic in about version 9, so quite a while now. And you will see this thread monitoring look and feel it's quite similar since version 9 and 10, so it's not something new as per 12c. They made some improvements as we will see, like they are keeping track, let's see, of the started time of the thread, as we can see here. This is fairly recent, but overall the look and feel is pretty much similar. So this is the summary tab, and this is where it gets useful, because each thread you will get the thread name, which is actually get the actual ID of the thread, total requests executed by this thread, then you get the current request, which is, for example, it could be an HTTP request in this case, or an RMI call, and then you get all the different counters. If it's idle, right, for this counter, stuck, and hugger. Very important, right? A hugging thread or hugger simply means a thread taking a bit of time doing always the same thing, right? So let's say you have a thread which is running since about 10 seconds, doing the same task for 10 seconds. So WebLogic will promote it to true, hugger true. And then depending how much elapsed time the thread is executing the same request, right? Again, the same request, then we promote it to stuck. But stuck is a configurable time. So in this environment, what we did is this. If I go back to the server, there is a tuning tab, and you get a stuck thread max time. In our case, the default is 600 seconds or 10 minutes. So meaning that WebLogic at some point after 10 minutes will identify a thread as stuck, right? And then it will print out in the actual log the full stack trace of that thread. Okay, it's a very useful mechanism when you're troubleshooting problems if you're dealing with stuck threads. If you're using Work Manager, WebLogic may also take some decision. Let's say if you detect stuck thread, to turn off the Work Manager, but we're not going to talk about this right now. In this scenario, as you can see, we did reduce it to 60 seconds because we're going to demonstrate also stuck thread as well. Okay, so let me go back to the monitoring, and then we'll get started with the simulation. So in order to do this simulation, what we did, we created a simple program. As you can see, this is pretty much the Eclipse or the enterprise version for WebLogic. So as we can see, we created a very simple Spring MVC application with two controllers. One which is called Hugging Thread Controller and one Stuck Thread Controller. Each of them associated with a JSP file for the rendering of the page. Okay. So what the Hugging Thread Controller does is it's very straightforward. It simply executes that method, hugging thread, and then it does a thread sleep inside a synchronize block. Thread sleep for 30 seconds. So the goal is to replicate hugging threads, so you were able to see in the console hugging thread in action. You see, it's always best to learn with a simple example before you go into more advanced problems. Now, if you look at the stock threads, very same logic, but we do a thread sleep with no synchronize in this case, but we do it for 90 seconds. Remember, right, we set up the stuck max thread time at 60 seconds, so with that controller taking 90 seconds to execute, the goal is to replicate the stuck thread problem. Okay, so let's get started with the actual simulation. Okay, so I'm going to execute a request. As you can see, that was from a past request. I'm going to retype and refresh this. As you can see, it's still loading because we put that thread sleep. Now if we go to the actual page, let's see here. You see, I did two requests. You see, one started in 7 seconds, 6 seconds. If I do a refresh, you see, now that same request, 18 seconds, 16 seconds. Now if you look at the application auto-generated URL file from Java, which is my URI of this sample application, The EF file is auto-generated because we're using WebLogic was started from Eclipse, so in this case it's using auto-generated name. That's why you see this as an application name. But this is essentially our sample application. This counter is set to true. You see, higher thread true, right? Because remember that that program is starting, is sleeping for 30 seconds. And this is why. So this is why it's very useful to monitor, because when you're getting to some sort of situation, you're able to do a live monitoring and you're able to trace down that these thread, right? In this case, thread 7 and 8, taking too much time. Now, if we do a refresh, obviously these threads are gone. So let me send a few more requests. And you can see now we have 3 threads, right? Or 4 threads in this case. Fix again, 6. Extend send request. Now, the other function, as you can use a dump thread stack right away. So this function, if you're familiar with it, is essentially a JVM thread dump that you can do directly from the console. Okay, so that's a facility in WebLogic. It's quite useful. It generates the thread dump JMX format. So it's really nice when you're dealing with thread like this, you're able to do a quick analysis. If you look at this thread, right, 22, this thread is in block state. It's waiting at this line. You see, this is where it's interesting, right? Hugging thread. This is exactly our controller, right? pH at line 37. It's blocked. Now let me go at this line in the code. You see? Line 37, you see? So that thread is pretty much blocked here. Okay? And then you see this thread you will see is sleeping. 18. This one is in time waiting, right? Because that thread is sleeping because we're waiting for 30 seconds. And if you look at the other threads, you see, you will see some of them also in a block state. Why are they in a block state? Well, this is where you see the limitation of this thread dump. The thread dump from the WebLogic console is not necessarily a native thread dump. It's not giving you the native information on the thread, so you're not getting a detail like which object monitor it's locking. This is why we wanted to show that to you, because you need to understand the limitation. The reason it's in block state is because we're allowing only one thread, right? Because what we did, we created a static lock or a semaphore, right? And then we're synchronizing on the static lock. So we're pretty much allowing only one thread at the time to sleep to this method. So in this case, it means one thread will sleep and the other request will queue up right here, right? And wait for an object lock on the monitor, which will be held by another thread. But as you can see, you won't be able to see this in a thread dump from the console. So you need to use a native thread dump, as you can see, right? This is why you see this one is a block state. So let me go back to here. What we're going to do, we're going to show you how you can do this very quickly. I'm going to send a few more requests. So what we did is we also fire up JVisualVM, which is definitely a tool that I recommend, and then you can definitely generate a thread dump from JVisualVM, and in this case it's going to be a native thread dump. So when you need to do quick assessment, it's good to use the console. If you detect some blocked thread and you need to worry about object monitor lock, then use a tool like JVisualVM. Or if you're using a Unix-based OS like Linux or Solaris, then just do a kill -3 of the PID, right? And that will give you this information. You see, the native ID plus the lock. You see, thread is blocked as we saw from the console, but now we know what it's waiting to lock, right? Waiting to lock. So we know that thread is waiting to lock on another thread, right? Which is desynchronized. So if I continue, this guy also, you see, 358, you see, same object because we have a global lock here. This is our guy, you see. So thread 17 is in sleep mode, but before going to sleep mode, it did acquire a lock on the object. 358. This is why, and this one is in time waiting because the thread is sleeping. So this is why you see the other thread are waiting to acquire a lock, right? but we could not see that in the thread dump from the console. So again, this is to show just the limitation, just to keep that in mind. When you're dealing with thread lock contention, always use monitor or analyze the native thread dump. Okay? So now back to the program. I'm going to demonstrate you now a stock thread. Remember, we created another controller that we call stock thread, right? So it's just like this. I'm going to execute the request. Now remember, the stock thread, it will be sleeping for 90 seconds, so we'll be able to trace down these threads. So I did generate quite a few requests, as you can see, right? Hunting thread is already 3. And remember, we did set up our stock thread max time at 60 seconds, so it will take about 60 or 65 seconds before Weblogic is able to identify our thread as stuck. And I'm going to clear the actual screen so I can show you what Weblogic is going to do after it detects that thread are in stuck state. You can see now at about 30 seconds. You see, it's very useful to track these threads like this. And at some point you will see, just follow up the counter, right? Another refresh, we're closing in about 45 seconds, 50 seconds. You see, so if you're using a real world application, you're able to monitor also your application thread using exactly like this. Oh, there it is. We have some thread now, you see, stuck. True, you see that? Now we definitely have some thread in stuck state. And notice the state here. You see? It's very important to realize that Weblogic, once it detects a stuck thread, and I'm going to generate another thread dump while this thread are actually stuck right here. Okay, there it is. And then I'm going to explain you quickly this principle. So as you can see, when you see these threads, you'll see them in active state, right? But as soon as the stuck thread is reached, Weblogic will update the state in stuck. This is part of the thread name, okay? So what it means is that when you investigate a thread dump from a Weblogic environment, it's always good that you search for stuck, because since Weblogic is updating this to the thread name, it means that stuck will show up in the thread dump. So if you do have any stuck thread, these will show up in the thread dump within the thread name. So this is really a nice add-on by Weblogic. Even though the thread is healthy from a JVM perspective, Weblogic is able to detect it's stuck and it will show up in a thread dump. We can see it here, right? The thread dump we generated from JVisualVM, you can see a few of them are inactive. Look at this. You see, this is a native thread dump that we generated from JVisual console, right? This guy is sleeping for 90 seconds, so beyond the stock thread max time limit that we configured, and Weblogic will automatically update the thread name right here. So the ID remains the same, but instead of active, you see stuck. So it's very useful because once you see this, you will know since how long the thread is executing, right? Let's say you're doing a root cause analysis after an incident. In addition of this, let's say you didn't have time to take a thread dump, which quite often I see is it could happen. Well, Weblogic, another good thing is that Weblogic will print out at least the thread stack trace in the log for you. So this is very useful if you don't have any monitoring tool or any mechanism like auto-generated thread dump. So at least you'll get a trace if you're dealing with stuck threads. As you can see here, right, 604, Weblogic was able to detect that thread 22, right, the one we're looking at, has been working this request for 65 seconds. You see? So in this case, showing us the print stack trace, and as long as you have the stack trace, then you're able to know which execution path this thread is doing. And in this case, it's exposing our program code, which is doing a sleep from the stock thread controller, which is precisely what we wanted to demonstrate here. Okay? So again, use the console as a starting point for live monitoring. For historical data, use a monitoring tool of your choice. There's a lot of commercial product out there and open source product as well, like JVisualVM. And again, very important that you understand that thread monitoring tab. So you start monitoring, and then when you're more comfortable, start to drill down into the thread dump analysis as we explained. Start with the console like this, dump thread stack, and then when you're dealing with more deeper thread log type of problem, use tool like JRoll VM or kill-3 to do kill-3, generate multiple snapshots about 5 seconds with each other, and then at some point you'll get more experience and you'll be able to do that type of analysis fairly quickly. Okay, so I hope that you appreciate this WebLogic thread monitoring training today. Please feel free to post any comment. You will also find reference to the articles from my blog below, so please feel free to post any question. Okay, so thank you and have a good day.